So Susa Niiranen she's a marine ecology and a researcher at the Stockholm Resilience Centre, where she co-leads the human ocean research team together with Robert Blasiak, who is also here. And her research focuses on studying the combined effect of human-induced stressors on marine ecosystems. And she leads the risk assessment work for the Mission Atlantic projects, as I just mentioned. So thank you, Susa. I can see you have shared your screen. Everything seems to work, but not your microphone.
No?
The microphone now seems to work. I can hear some noise.
Yeah, nothing else worked. So I need to try to share again. It got stuck somehow. Sorry for that. Another try. Let's see. Do you see my screen now? No.
Not now. Before we were able to see it.
Yeah. I thought I was well prepared, but then something went wrong. So let's see. Do you see it now?
Yeah, it's working.
Great. So I will start then. Thanks, Patricio, for the introduction and also the introduction to the Mission Atlantic. So that saves me a lot. And good afternoon or good morning to everybody from Helsinki, actually. I'm going to be talking today about uncertain ocean futures, assessing multiple risks as part of the Atlantic Integrated Ecosystem Assessment. And as Patricio already mentioned, this is very closely coupled to the findings and the work we are doing at the Mission Atlantic project. Still stuck? Now it works. So what I would like to remind you at the beginning is the role of humans in the ocean systems, as well as in so many other ecological systems. There's hardly any space, marine space or ocean space, that the humans do not influence nowadays. And there are often very strong couplings via multiple interactions. And this means that these human social ecological systems of oceans and marine systems, they are very complex and they are adaptive. And that also makes them very difficult to project. And if you take a look at the right-hand side figure, we as marine scientists often tend to focus on the lower part of this globe, and that's the marine system. And then we take into account often the proximate interactions. So for example, regional and local fishing, pollution, nutrient loadings. But sometimes we do forget the more distal drivers. So for example, technological development, it could be the tendency to urbanize nowadays, as well as, for example, the global governance and institutions. So I would like you to keep all this in mind when we go through the risk assessment, also in relation to the Mission Atlantic. And the most direct ways the humans influence the ocean is extracting the ocean resources and using the ocean space. And this is a paper by my colleagues from the Stockholm Resilience Centre, published a couple of years ago. And they found that the human activities are actually moving a bit more from the land towards the sea nowadays. And they call this the blue acceleration. So within the past 20 years, one has seen this really steep increase in many of the ocean sectors and activities. Of course, capture fisheries is not one of these. And if we combine that to the climate change that we experience nowadays, also in the Atlantic, we realize that we are kind of moving towards novel spaces. So this figure is from the Baltic Sea, which is on the right-hand side. But for example, if we take a look at the Baltic Sea temperatures, we see that already around 2050, we are moving towards temperature range that we have never measured in the Baltic Sea before. And I would assume this is the case in many of the other marine regions as well. And if we put this together with the close coupling with the humans and the environment, together with the acceleration, the blue acceleration I showed to you, it is quite easy to see that we are expecting a lot of uncertainties and surprises. And of course, the worst case scenarios are that we are crossing these tipping points and regime shifts are caused, taking us to ocean states or marine states that are not so favorable, particularly from the human perspective. So with this backdrop, it's not so difficult to see why risk assessment is needed. And there's a couple of risk assessment definitions that are out there, which are pretty general. So the first one is that risk assessments, they quantify the probability of undesirable events and their consequences. And then if we look more on the ecosystem side, it is said that they qualitatively or quantitatively determine risk to an important ecosystem component given change in ecosystem pressure or management actions. And of course, optimally, these risk assessments, they're tailored for a certain well-specified management need or question. And often this risk, it is still, I think, in many of these, at least the quantitative cases, it's described as the kind of disaster risk. So you multiply the hazard, exposure, and vulnerability. And I've actually had a pleasure to have PhD students from Mission Atlantic visiting me in Stockholm. And one of them, Helen from Germany, has a really nice analogy of this. So she has drawn the hazard as a rain, exposure as an umbrella. So it depends how you hold the umbrella, if you get exposed or not. And the vulnerability as a cat standing under the umbrella. So cats don't really like rain, so they are sensitive to it. So I think it's quite descriptive of what we are looking for. And the risk assessment, it is really a integral part of integrated ecosystem assessments. And this is what Patricio put very nicely forward, how we do this in the Mission Atlantic. And you see that it really comes after the scoping, developing indicators, and the reference levels for the ecosystem-based management. And the risk analysis should also feed into management strategy evaluation and monitoring and evaluation in the end. And how we think about this in Mission Atlantic, where we have the 7 case studies that we are working with, and we try to put them together to also get the kind of all Atlantic view, is this. So it's a paper by Holzman and colleagues from 2017, and they have reviewed a lot of ecosystem risk literature, and they've created this matrix, and I really like it. So you go from different levels. So you have the very qualitative level towards the quantitative one, and then you have different classes. So you go from the very studying the single pressures, single subjects, and direct interactions towards studying multiple pressures, multiple subjects, and also the indirect interactions. And here, one should really aim towards the right corner, so hitting somewhere there. And that's what we aim with the Mission Atlantic also, because this means that we could describe the more cumulative effects due to these interactions and taking them into account. And also we could provide some kind of management reference points if we are a bit more quantitative in our analysis. But we are not there yet. But we have been working on different steps. So we start from the qualitative that Patricio also showed a bit, and we go towards the quantitative. And this is what we have done so far. It's very similar to what Patricio showed to you. This is one of the case studies, 1 out of the 7. And for the Mission Atlantic, we have chosen to use something called ODEM approach for the scoping and the scoring. So the very lowest bar of the Holzman graph. And ODEM, it stands for Options for Delivering Ecosystem-Based Marine Management. And what's nice about this approach is that it really gives you, all the experts and the stakeholders, it gives you a list of sectors, pressures, and ecosystem characteristics. And it's an exhaustive list. And in a first stage, they do select which sectors, which pressures, which ecosystem components are relevant for their case. And they pinpoint those. Then they make the connections between the sectors, pressures, and ecosystem components, as Patricio already mentioned. And that's the first stage of the analysis. So you get kind of this qualitative assessment, screening. After that, they do scoring. So they use this kind of disaster risk thinking. So they value using the hazard, once again, exposure and vulnerability, these different interactions. And that results in top risks. And this is what you see here. So in this particular case, for example, you have the top risk sectors, which is fishing and shipping. In the middle, you have the pressures, you have litter contaminants and species extraction and bycatch. And with the ecosystem components, it's a bit more varied. But this kind of what you get from the scoping and scoring, and for all the 7 case studies. And if we go forward, we also did further vulnerability analysis using these ODEM assessments. And what we did here is we tried to pull these results back to the all Atlantic level And here, each ecosystem component in each case, it was shown how many of cases this ecosystem component is affected by a certain pressure. And this is how we get this kind of grid. So if you have an ecosystem component that is affected by a pressure, in every case, you get a high vulnerability, for example. And this is something we need to develop a bit further, but it's also good complementary information that we can use when we are moving towards the more quantitative assessments. And unfortunately, we are still really at the lower bars of the Holzmann graphs, and we should move towards the right-hand corner. And this is the next stages that we are working with currently. So if you take a look at the number 3 here, that's our aim. So we would like to end up with 7 semi-quantitative or quantitative risk assessments, focusing now on the key risks that were identified by the ODIM approach. So we don't do everything, we just do the risks, the sectors, pressures, ecosystem components that the stakeholders and experts have identified as the key ones. What we want to study here really is now focusing more on the interactions between sectors, drivers or pressures, as well as ecosystem components. So we like to get this more cumulative perspective into this also. And this is going to be done using the Bayesian belief network methods. So we have this kind of probabilistic outcome of this assessment. And how we can do this is why I think the project like the Mission Atlantic is really nice, because we have a really broad expertise within the project. We have very many different tools and methods. So we combine the statistical analysis that we have on pressure indicator relationships already from the project. Also the mapping and the modeling and monitoring work that's done. And we try to match that with the stakeholder needs from the ODIM assessment and put that into the Bayesian belief networks. And at the same time, we ground truth this with the stakeholders and experts. So then finally, what I want to show to you, so that was how we are planning to proceed with the Mission Atlantic. What I show here is a paper from 2 of my colleagues from Stockholm, and they did a literature review on risk assessments. And they identified 5 challenges for assessing sustainability risks. And how I like to use this is to kind of mirror the work that we do in the Mission Atlantic with this, and how well do we do. And they had identified 3 key challenges when it comes to variation across time. So how predictable is the system, randomness, backcasting, forecasting, is it appropriate? And what is the time horizon we look at? And if we look at the Mission Atlantic, I think we do okay with the randomness. We have good expertise, we have models that can be probabilistic, and we have the expert judgment, but we still need to be careful here. Backcasting, forecasting, it's very easy to see if you take a look at the novel spaces that we are getting into regarding temperature and the extensive use of the ocean space, that maybe we cannot use the what we used to think about the system, how it works, to project the future. And this is an issue for us also who use a lot of model results that are actually calibrated with historical data. So, and 50-50, the other 50 comes from us being aware of this, and also that we have the expert and stakeholder knowledge. Time horizons, I think we are pretty good with, and all the case studies have been very good with communicating with their stakeholders what time scales we are looking into. Then are the 2 connected risks. And I think with the social ecological risks, we could be a bit better. And I think we have a lot of potential here regarding the ecosystem service work that we are currently doing within the project. And what I think is the most important, or interesting actually, I don't know if it's the most important, but I think this is the most interesting part, at least to me, is these distal and proximal cross-scale dynamics. So we have a really big chance here because we have 7 cases from all over the Atlantic, and they are all affected by at least some set of the same distal drivers. And they also together, there may be something emerging to the all Atlantic scale. And I think we should put our heads together and really think this through. How could we contribute towards this cross-scale dynamics and understanding that better in the risk assessment? So this is my final slide. These are some of the future action points. I call it a wish list because when I read through it, it's really like, it's a bit like that. So the first one, of course, this is a big one, but it's developing holistic risk assessment methods that are of high relevance to society and can account for potential nonlinear cumulative ecosystem effects and trade-offs between different pressures and sectors needed. So really the right upper corner that we should hit. Developing risk assessment methods that can reliably account for uncertainties and effective communication of these uncertainties. I think this really is key. We are trying to do this with its probabilistic methods, but I think we need to be very clear in our communication. The third one I think is super important when you think of the IEA, and that we need to have something that we can use for the monitoring. So on the indicator way and the kind of levels that we can monitor, so something quantitative. And this is the identification and data collection for suitable quantitative and qualitative also indicators relevant for sustainable production of ecosystem services, and particularly those related to emerging sectors. So this also has to do with the timescales, what we are talking about, but I think this is particularly important if we take a look at that blue acceleration curves that I showed to you. And finally, this is a lot of my own curiosity, but I think it's super interesting with these cross-scale and cross-level interactions. And I think it's getting more and more important when the world is getting more and more connected. So that was everything from me.
Thank you, Susa. Very, very inspiring presentation. And while I invite everyone to put questions in the chat or in question and answer, if you can see, and I'll try to kind of go through them. I want to make one question because you touched upon these tools somehow, and this occasion is also a way to brainstorm a lot about potential tools and what is missing and what is available out there. So you mentioned that the use of this Bayesian belief network that have been, I mean, you have been using basically for risk assessment so far. Do you think that's, how to say, I mean, there is space for improvement on that tool? So there is like, you need to go into a radical change of these tools into more kind of, I don't know, machine learning oriented or other type of statistics or things like that, in the way you are moving from kind of a simplified system into the more complex systems that you showed with multiple actors and multiple processes that are addressed?
I think with the machine learning, maybe Mike can probably has his to say, but I think the first thing, now that we've worked with the case studies a lot, it's the careful design of what is included in these networks and what is the data that you put in. So maybe there the machine learning also comes to play a part. But I think currently it's we need to be very careful with the design, and I think the tool is there, and it's not very. We just need to be good at using it, I think.
Okay, well, thank you. It's definitely something we can expand upon later on in the roundtable.